Good morning, chemistry students. Today we are actually looking at the last type of nomenclature, the last set of rules, still working with standards E and F, where we're looking at the patterns in our nomenclature and trying to write names and formulas for our compounds. So our last type of compound is our covalent compounds. Remember from Unit 1 when we learned about our intramolecular forces, covalent compounds were compounds where elements shared electrons because they had similar electronegativity values. If we look at covalent names and formulas, notice some of the things that are similar and some of the things that are unique to just our covalent. Now, it is interesting to note that covalent compounds will have either just two nonmetals or a metalloid and a nonmetal. For our purposes, we're going to make the general assumption that if it's a metalloid in the compound, that it's going to form a covalent bond. There are a few exceptions, and when we get to polarity a little bit later in the unit, we will see those few exceptions. But for the most part, metalloids and nonmetals form covalent bonds, and then, of course, our two nonmetals always form covalent bonds. And the way these elements form those bonds is by sharing electrons. So they share their outer valence electrons in order to achieve their octet, which means they don't form ions. So we don't actually have to look at the periodic table to determine the charge. We just have to look at the periodic table to determine the symbol if we don't already know it. So when we look at the names and the formulas, I want you to notice that all of the names end in IDE. This is similar to our binary ionic compounds, where if we had two uppercase letters, that last name ended in an IDE. The thing that is different is we have added these prefixes, these things that indicate numbers. So tri, di, tetra, mono, those are called prefixes, and they are used to tell us the number of atoms for that element. Because our elements can share electrons in a variety of ways, we have to indicate the number of atoms using a prefix. So if I'm giving you the formula and I'm asking you to write the name, it's really, really similar to type 1 ionic. You just have to add those prefix names. So you would write the name of the first element. You would write the name of the second element. You have a phone call. Changing that ending to IDE. Remember, you're just keeping that first syllable, the first part of the second name, and then you're ending it in IDE. And then you add your prefixes to indicate the number of atoms present within the compound. Now, there is a little rule about never using mono for the first element. I don't make the rules. We just have to follow the rules. So we don't use mono on the first one, but we could use it on the second, as we saw in one of the examples before. But the prefix tells us exactly what our subscript will be, or what our subscript is. Now, there are a couple of covalent exceptions that we will see in this course that I would like for you, ladies and gentlemen, to memorize. First and foremost, you probably already know is water, and of course, they're out of order. I love it. H2O, chemists do not typically refer to it as dihydrogen monoxide. It is just traditionally referred to as water. So H2O typically is referred to as water. There are two others that we will play with that you'll see quite a bit when we get into chemical reactions. I kind of expect y'all to know their names. The first one is ammonia, NH3, or the second one is ammonia, NH3. It doesn't follow the actual rules for covalent nomenclature. And then the last one is methane. There's actually a whole nother branch of nomenclature that we're not getting to, and that actually comes from there, but we use methane quite a bit when we get to combustion reactions. So those are just three exceptions, but all of the others, the subscripts become a prefix. So let's look at three quick examples. So example number 1, CCl3. So notice two uppercase letters. Covalent compounds are all binary. They all have two atoms. So I'll write the name of the first element, carbon, write the name of the second element, chloride, and then I add my prefixes. And I haven't shown you all the prefixes yet, so I will put them up on the screen right after this example. But my prefix for 1 is mono. My prefix for 4 is tetra. We don't use mono on the first element, so this thing's name is just carbon tetrachloride. Carbon tetrachloride. And before I forget, here are all of the prefixes. You're going to want to either have them written down, memorize them, have them easily accessible. The easiest way I've found for students to learn them is to quite literally practice counting them aloud on their fingers. It makes that connection to how you learned how to count when you're little. So it kind of makes it stick a lot easier. So mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. There are a couple other ways that you can remember it. 1, monologue is one person talking. 2, die, I think of a paradise. 3, try, triangle, tricycle. That lets you know you've got 3 things. Tetra, I'm going to show my age. I think of an old school game, Tetris, which is a game of boxes. And they happen to all have 4 sides, and they happen to all have 4 sets of boxes. The rest of them are based off of your geometric shapes. So penta means 5. Hexa, I think about that X to remind me that it's 6. Hepta is the only one I don't have anything cute to remember it. Octa, I think octopus, 8-legged sea creature. And 9, nona. It's the only one with an N, so it kind of makes it make sense. 10, deca. Decade is 10 years. So knowing that, let's look at our last 2 I do examples. SN2, let's try again, S2N1. S2N1, so I'll write the name for S, which is sulfur. N's name is nitrogen. I keep the nite, and I replace the gen with an IDE, nitride. And then I add prefixes to indicate the number of atoms. So my prefix for 2 atoms is di, so disulfur. And for 1 nitrogen is mono. This thing's name is disulfur mononitride. And last but not least, I'm actually going to write the prefix as I write the name, which is one way of doing it. So I see that I have 3 N's, so I'm going to write tri nitrogen. I see that I have 7 bromines, so I'm going to write my prefix for 7, which is hepta. Heptabromine becomes bromide. Bromine becomes bromide. So that's getting the names from the letters. The nice thing is when you're going in reverse, it's actually considerably easier. When I'm giving you the names, I'm actually telling you what the subscripts are. So you're going to have to use those prefixes to determine what the subscripts is. You use the name to determine the symbol. Now, you do have to remember that that second element was changed from its normal name to an IDE. I have found that some students find it easier to just kind of list out what those IDE names and symbols are. So like they would list ox, ide, and they would show that it's an O. Or they would list chloride and show that it's a Cl. Now, I don't want to actually show those charges because with covalent, they don't have a charge. Yes, I know, ionic, they do. So general way for covalent, just to kind of keep it straight, is you're writing what the name says. The name tells you exactly what to write. It tells you exactly what the subscripts are. So you do need to know those prefixes. So this example, dicarbon hexafluoride. Dicarbon is telling me 2 carbons. Hexafluoride is telling me 7 Fs. So I have 7 Fs. Remember, we put the number of atoms after the symbol. We say the number of atoms in front of the name. So phosphorus, there's not a prefix here. That means I only have one of them. Tribromide. Tri means 3. So I have 3 bromines, PBr3. And last, I do example, trinitrogen tetraselenide, trinitrogen N3 tetraselenide. Okay, I don't find selenide on the table, but I do find selenium. That first syllable is there, and it is Se, and tetra is 4. So N3 Se4. Okay, so pause the video, see if you can write the names or the formulas for the examples on the screen. Remember, I'm not going to count off for little spelling mistakes. So little bitty issues, not a big deal. So for 1 through 4, I'm giving you the letters. That implies I want the names. These are all covalent nomenclature. I know they're covalent because they don't start with a metal. Covalent compounds all start with either metalloids or nonmetals. So N2O3, N2, 2 N's is dinitrogen. O3, 3 O's is triox. Keep that first syllable, replace that ending with IDE, trioxide. Number 2, ClO2. Cl, 1 Cl. Mono means 1, but we don't use mono on the first element. So this thing is just chlorine. Can't spell chlorine all of a sudden. Or I can't write an N, whatever. Chlorine dioxide. I don't think that's a real element, real compound, but whatever. Chlorine di, because there's 2, oxide. BF3, boron, tri, fluoride. Boron trifluoride. Number 4, 4 ASs. Well, 4 is tetra. AS, arsenic. I always want to say the wrong element, so I have to double check that particular one. So tetra, arsenic. You can drop the double A if you want. I've seen it written both ways. I keep it. But tetra arsenic, deca oxide. Or technically for O, they usually drop that double letter, so it's dec oxide. But close enough. Again, little spelling issues, not a big deal. All right, carbon monoxide. Hey, this is the stuff that can be produced by old furnaces and fires, and it's very, very toxic to humans. Carbon monoxide. Carbon is a C. Mono means 1. Oxide is referring to oxygen. So C1O1. Big C, big O. The size of the letters matter. Big C, little o is cobalt. It won't kill you. You can carry it around in your pocket. But carbon monoxide will. Diphosphorus pentaoxide or pentaoxide. Diphosphorus P2O. Penta is 5, so P2O5. Remember, practice counting your prefixes on your fingers. And nitrogen dioxide, NO2. NO2. NO2 is nitrogen dioxide. So you've got some covalent practice, guys and gals. These same exact rules apply to our fictional table exactly the same way they apply to our real table. So exact same thing, just slightly different names, slightly different symbols. As always, I'm available in the meet. If you've got questions, make certain you take advantage of me during class time. Usually covalent, most students find easier because for some reason, it's one of the few things y'all tend to remember from physical science. But don't get a little prefix happy. Only covalent compounds have those prefixes, and that's it. They're the only ones that get the prefixes.